Introduction to the type of the drawing, views, and perspectives. To read the drawings correctly, the user must have the basic understanding of the various categories of the drawing, views, and perspectives in which each drawing can be represented. This is the 5 drawing categories used in the engineering drawing. Categories of the drawing. The previous chapter reviewed the non-drawing portion of the print. The chapter will introduce the 5 common categories: drawing, the piping instrument drawing, the electrical single line and schematics, electrical diagrams and schematic, local logic diagrams, and printing, fabrication, construction, architectural drawings. Piping and instrument drawings. Pipings are usually designed present functionally information with a system of components. Example: the pipeline layouts, flow paths, pumps and valves, insertion, instrument, signal modifiers and controllers, illustrated in Figure 6. Example: the piping and instrument drawing, shown in Figure 6. As a rule, the piping and instrument drawing do not have the drawing scale presently with the relations of sequence between the components. The two pieces of the equipment are drawn next to each other. That does not indicate the plant equipment, even though the same building is just as part of the piece of the system. The drawings are only present information on how the system functions, not actually the physical relationship. The piping and instrument drawing provides the most concise format the how should and the function they are used extensively operating, repair, and modification of the plant. Electrical single lines and schematics. Electrical single lines and schematics are designed to present the functional information about the electrical design for the system components. They provide the same type of the information provided with the electrical systems that a piping and instrument drawing provides for the piping and instrument drawing system. Like the piping instrument drawing, electrical prints are not usually drawn to scale. Examples of typical lines are a site of the building, power distribution signal system, power distribution, motor control centers, and Figure 7 shows the example of the electrical signal line. Electrical schematics provided with more detailed level of the information. Electrical schematic component with the single lines. Electrical schematic drawings present information with the individual relays, relay contact, fuse, motor, lights, instruments, sensors. Example of typical schematics: value actuating circuits, motor circuits, and circuit breakers. As in Figure 7 shows the example of a single line schematic. Figure 8 is an example of the motor start circuit schematic of the electrical single lines. The schematics provided in the most concise format, depicting how the electrical system should function, are used extensively in operation, repair, and modification of the plant. So Figure 8 shows the example of the schematic. Electrical diagram schematics. Electrical diagram schematics are designed to present information about the individual components. These resistors, transistors, capacitors used in the circuit illustrated in Figure 9. The drawings are usually used by circuit designer, electronic repair personnel. Example of electronic ground diagram. Logical diagram prints. Logical diagram prints can be used to depict several types of information. Most commonly used to provide a simplified functional representation electrical circuit illustrated in Figure 10. For example, the easier, faster way to figure out the value of the function respond to the various input signals represented with the value. Circuits will use logic symbols than by using electronic schematics. When this complex relays in contact, these drawings do not replace the schematics, but they are easier to use for certain applications. Example of a logic print, like fabrication and construction, architecture and drawing. Fabrication, construction, architecture is designed to present the detailed information required for the construction, fabricating part of the system. The structure of the 3 types of drawings are different, that their only application opposed with the real difference in the drawings by themselves. The construction drawing commonly references the blueprint drawings represent the detailed information required to assemble and structure on site. Architectural drawings present information with the conceptual design of the building and structure. Examples of house plans, building elevations outside of the view of each of the structure, equipment installation drawings. The function fabrication of the drawings, equipment and assembly drawing. The fabrications are shown in the Figure 11 and similar construction architectural drawing, but are usually found in machine shops, provided with the necessary detailed information for a craftsman to fabricate apart. All 3 types of drawings, fabrication, construction, architectural, are used to draw to scale. Alright, this shows this is an example of a fabrication drawing. 2 bolts, kind of in like upper body and a lower post. Lower body, don't know what it is. It's a part. It's a boring bar holder. Okay. Drawing format, piping and instrument drawing, fabrication, construction, architectural drawing can be represented using the several different formats as hammer forms, a single line, pictorial, double line, or cutaway. Each of the format provides a specific information about the component system. Single line drawing. Single line format is most commonly used for the piping and instrument document. The Figure 12 is an example of the single line piping and instrument document. The single line formats represent all piping regardless of the size. Single line, all systems equipment represented with the single line. Simple standards and covered in the later modules. By simplifying the piping and the equipment signal lines allow the systems, equipment, and instrument relationships to be clearly understood by the reader. Figure 12 shows an example of a single line piping instrument documentation drawing. As you can see, the elbow T, another elbow, global valve, coupling joint, check valve, cross plug, union, reducer, 45-degree gate valve, Y fitting, and a cap. Pictorial double line drawing. Pictorial double line drawings represent the same type of information single line, but the equipment is represented as it has been photographed. Figure 13 provides an example of the information. Pictorial drawing, the format is rarely used with the sense that it requires much more effort to produce a single line, but the drawing does not present any more than information with the system function. Compare with the pictorial illustration figure 13 with the single line with the system, same system figure and shown in figure 13, figure 12. Pictorial double line drawings are often the advertising training material. Alright, figure 13, as we go over it again, the elbow, the T, the elbow, and the coupling joint, the global volt, the check volt, the plug and cross, union, reducer, gate valve, elbow, Y footing, and cap. The assembly drawing, also special application pictorial drawing, commonly used in engineering, shown in figure 14. Assembly drawing is pictorial view of the object of the component shown in figure as they go together. With the typical pictorial using found with the vendor manuals used in parts identification and general information. Relatively assembly component drawing. This is an assembly drawing of what looks to be a valve and cutaway drawing. Cutaway drawings are another special type of the pictorial drawing. They cut away the names and they implements the component and the system of the portion cut away with reveal the internal part of the component system. Figure 15 illustration of the cutaway. The type of the drawing is extremely high importance maintenance training area where the ways internal parts are assembled and important together. Figure 15 is a cutaway wheel. As you can see, it's a valve with a plunger and springs. No, with a cross flexure, it just like. Views and perspectives. In addition, with different drawing formats, there are different views and perspectives in which the formats can be drawn. The most commonly used is the orthographic projection with the isometric projection. Orthographic projection is widely used fabrication construction type drawings shown in figure 16. Orthographic projections present comments to the system through the use of three views: the top of the view, side view, and front view. The views are such a bottom view and are used to more fully depict the component in the systems when necessary. Figure 16 shows an orthographic projection of a house, the front end, the roof plan, and the right end of the elevation. Figure 17 shows how each of the three views obtained with the orthographic projection is drawn to scale and shows all the components of the projection relationships into the other. The three views will provide with the dimension drawing scale containing information necessary to fabricate the construction components of the system. And as you can see, they've taken this 3D life 3D drawing and drawn it into a particular projection with the line of sight drawings at frontal, horizontal, and the two right side and right side and horizontal and side line of sight. Isometric projections present a single view with the components of the system. The view is commonly from above at an angle of 30 degrees, provided with a realistic three-dimensional view as shown in figure 18. But the view makes it easier to see how the system looks and how the various portions of parts are related to another. Isometric projections may or may not be drawn to scale. Like this one shows a fuel tank, oil tank, fuel lines, fuel oil tank, reverse pressure lines, the gate valves, bypasses, rotary fuel, oil. Check out UFC Petroleum Design if you're into this. I have that posted on my YouTube if that's what you're looking for, petroleum drawing scales. Summary, the most important information chapter to summarize the drawing type of the views, perspective summary, 5 engineering drawing categories, piping and instrument drawing, electrical single line and schematics, electrical diagrams and schematics, logic diagrams and printing, fabrication, construction, architectural drawings. Alright, Department of Engineering Fundamental Handbook, Engineering Symbols and Prints, Drawings, Module 2, Engineering Fluid Diagram Prints.